interested persons around and all over the world. Probably I can understand out of the interest people can really get interested with the topic, and it's nice to welcome you all over here. I think with some more time for waiting, so that for the interest of larger audience, we can wait and start. As Dr. Giraj suggests. So, Dr. Giraj, I think, shall we wait for some time?
Yes, we will wait for a few minutes, then we will start.
Okay, fine.
So, hello and welcome you all to the 9th talk in the series of webinars started from 11th May 2021. I most welcome our director, ma'am, Dr. Neeta Khandekar, ICAR Indian Institute of Soybean Research, Indore, and Dr. Sanjay Gupta, head crop improvement section, IISR, and also in charge of AICRP on soybean. As soybean is a rain-fed crop, and due to the ongoing climate change phenomena, drought stress is frequently associated with significant yield losses in soybean. So it demands that newly developed varieties should have intrinsic drought tolerance capability. So today's topic focuses on important theme lecture, phenotyping strategies for screening of drought tolerance in soybean, to be delivered by Dr. Gyanesh Kumar Satpute. I have a privilege to introduce him. Dr. Gyanesh Kumar Satpute is a senior scientist in genetics and plant breeding discipline at Indian Institute of Soybean Research, Indore. He is working on breeding soybean varieties for drought tolerance for last 9 years. Recently, NRC 136, a drought-tolerant variety developed by him, is released for Eastern Zone. He is associated with phenotyping of Jiva's panel for drought-related traits under National Agriculture Research Fund (ICAR). He is recipient of travel grants for participating in Committee on Space Research Assemblies twice, and he has won external research grant for his research on characterization of soybean germplant. He had been awarded postdoc fellowship by Spanish Ministry of Education to work at CSIC CIB Madrid. There are about 30 research articles published in research journals, magazines, and review articles in books of international repute. He has many germplasm assessments registered with NBPGR database and 3 notified varieties to his credit. So all set, I invite Dr. Satpute for his talk. We have planned the talk for half an hour, which will be followed by question answer session and discussion in the area. Also during the lecture, you may send your queries in chat box that may be given due weightage during question answer session. Dr. Satpute, please continue. Unmute, sir. Please unmute, sir.
Okay.
Yes.
Am I visible or audible? Hello.
Yes, sir. Audible.
Audible. So full screen कर दीजिए, sir.
Okay. Hello. Good morning to everyone here from India, and hi to everyone all over. This is today's topic I'm trying to present is phenotyping strategies for screening of drought tolerance in soybean. It's a formulating a new approach towards abiotic stress management. I am Dr. Dhyanesh Kumar Satpute, as I have already been introduced, and my coordinator, Dr. Jiraj Kumar, and all the participants. I welcome you all. I welcome my respected director, my senior coordinator, Dr. Sanjay Gupta, and all senior colleagues from Indian Institute of Therapy Research, and for all the participants all over. Just to begin with the introduction, the crop, as you all know, and whosoever is new to the soybean crop, I don't understand. Soybean is an important oilseed crop of the country and worldwide, enriched with good quality protein, edible oil, nutraceuticals such as isoflavones and tocopherol, and biofuel properties. The crop suffers yield losses and quality of seed to a greater extent due to frequent and unpredicted dry spells during once in every 5 years in the face of climate change scenario. Increasing soybean productivity by targeting breeding for yield per se is challenging as productivity for release in new varieties gets stagnated under such situation. Drought tolerance being governed by a complex set of traits, there are multi-level challenges for the breeders to develop a climate-resilient genotype. The major challenges being defining target population of environments is the foremost challenge, and designing strategies for growth stage specific improvement is another important challenge to the plant scientists. Some interesting facts I would like to share about water requirement of soybean. The water requirement of the plant vary according to the growth stage of the plant. Young plants transpire less due to the smaller leaf surface. Soybean water requirement are the highest from flowering to seed filling stage. The middle to late reproductive stages are therefore very sensitive to any moisture stress. In order to get optimal soybean production of say 3,000 kg per hectare, with water use efficiency of soybean varying between 4 kg to 7 kg of grains per hectare per millimeter of water usage, that is coming to average of 6 kg per hectare per millimeter. The crop water need of the soybean ranges from 450 to somewhere 450 to 700 mm per total growing season. Looking at the small calculation, you can say that 3,000 kg grains per hectare or 6 kg per hectare per millimeter of water. This will lead to 500 millimeter of water will be needed to produce a yield of say what we expect from the crop. So another interesting effect about the soybean is that in terms of water requirement is that late maturing group will need more water to their total growth period than a cultivar with early maturing group. So a kind of statutory warning is that the higher plant population requires more water, and therefore lower plant populations are recommended for dry land conditions than for high rainfall areas. And secondly, minimum tillage practices and good mulch reduces the evaporation of moisture from soil surface and increase infiltration of rainwater. So the practice of minimum tillages and good mulch is required. As regarding drought understood, for the understanding of larger audience, drought resistance, the food security in the 21st century will rely increasingly on the release of cultivars with improved resistance to drought conditions and with high stability. So drought resistance is measured by phenotyping the specific and relevant attributes of dehydration tolerance and dehydration avoidance, where a concrete breeding program integrating robust, reliable, relatively fast, and economical phenotyping facility. So, as already told, that like dehydration tolerance phenotype only on the basis of similar plant water status in all the genotypes, including the most prominent feature of whole plant dehydration tolerance, assessing the capacity of stem reserve utilization for seed filling, particularly during drought stress. So protocol for dehydration avoidance, including measuring plant water status in terms of visual symptoms of leaf senescence, relative water content, canopy temperature, and seed traits such as drought resistance index, and constitutive traits without exposure to drought stress events such as root system architecture. So as we can see there's a large number of drought related traits, right from morphological to biochemical to root traits to shoot traits. So uh, it is very difficult. The very first thing is that selection of trait is very important, and from the breeder's point of view, the trait should be such that it can be efficiently and very precisely and very rapidly can be measured, so that large amount of populations and germplasms can be screened at a particular growth stage within the given period of time. So looking to the need, a specific need, and facilities are accessible with the institute and resources available, some few traits that really contribute to that drought tolerance can be selected and harnessed for that particular purpose. So in that series, the delayed leaf senescence is a trait. It's a dehydration avoidance trait, and delayed leaf senescence induces extreme drought tolerance. And scoring of delayed leaf senescence trait on 1 to 5 rating scale in soybean that has been standardized with a high score of 5 and very low score of 1 being the indicators of relatively better dehydration avoidance, and was perfected for off-season field screening of large number of germplasm accessions and feeding lines by imposing drought stress by withholding irrigation at pod initiation stage for 21 days. Another trait is stem reserve mobilization trait. It's again a dehydration tolerance trait, and an important component of reproductive success of the crop, and the capacity for seed filling from the stem reserve when transient photosynthesis is inhibited by stress. The utility of chemical desiccant method in soybean using potassium iodide at 0.2% weight by volume, spraying the whole canopy at seed filling stage, that is R5 plus 8 to 10 days, was confirmed at Indian Institute of Soybean Research for field evaluation of large number of genotypes and identification of genetic resources for stem reserve mobilization at a terminal drought. Above ground plant water relation and seed traits talking of from it's a kind of experiment that has been conducted previously, and what I'm trying to say is show here is in the growth condition of X seed fill stage in 21 days rainout shelter control drought stress at soil moisture of 17% and plant water status of 67% RWC, that should be lower than 70% anywhere. So these characters, the list of characters above ground characters can be recorded, including relative water content, carbon isotope discrimination, canopy temperature, reduction in pod field moisture, specific leaf weight, drought resistance index for seed yield, drought resistance index for 100 seed weight, increased number of nodes, increased number of plot, increased plant height, and increased 100 seed weight. As far the plant water relation traits are concerned, for the same growth condition at seed filling stage in 21 days rainout shelter control drought stress, you can see plant canopy temperature depression is well associated with increased number of nodes per plant and increased 100 seed weight. It's really good information that can be harnessed for breeding for drought tolerance. Uh, as regards the root system architecture, which is the below the ground traits, are really very crucial for breeding for drought tolerance. And it is actually a set of constitutive traits affecting dehydration avoidance in soybean, and it was standardized at the growth condition at flowering stage using, you can see here, in lysine.
डाल देना आप जितने, फिर हम काट देंगे अपने हिसाब से, ठीक है ना?
I think should be muted. So using lysimetric PVC pipes, as you can see, they are of the height of say some 5 or 6 feet, particularly 6 feet high and 8 inches wide for this particular plant of soybean and its canopy. These plants are grown initially in individual pipes. We grow some 3-4 seeds, and at some say at seedling stage, rest of the plants are removed and the healthy one is kept. So one plant per PVC pipe, and these plants are allowed to grow till flowering stage, and that is the stage where these pipes are taken out and they are washed in a structure mesh on the mesh, and the soils roots are washed out, and they are bring back to the lab on the for analysis in Winriso Arabidopsis root scanner, and software is widely used world over. So this very system has the advantage of assessing almost 7 traits you can expect for the roots, and as you can see here, the rooting depth, length, root length density, root angle, and root penetrating traits are like number of forks, number of crossings, number of tips, and similarly water extraction traits like root fineness and root surface area can be harnessed. You can see here the rooting depth, the association of rooting depth is well associated with root angle, root penetrating trait, and profuse water extraction trait. You can see the rooting depth in soybean, it is almost from 1 meter to 2 meter, depending on the genotypic variability found in the germplasm collection. The root angle from the soil surface is an important, very important criteria, which ultimately affects all the most of the root parameters, including root penetrating trait like length. This length is different from rooting depth. Rooting depth is the total length from top to bottom, while this length is the cumulative length of all the roots coming out from the main root, including the main root, and that cumulative length is this length which is measured by the Winriso. And then there is another trait, number of forks. These are the forks, and then number of crossings. So these 3 traits are like they are root penetrating trait, and as you can see here, that these 3 traits are well correlated, found well correlated. And then there are water extraction trait, and these water extraction traits are actually important at the lower side of the root, and also in the upper soil surface, where in fact it is all over the root. If these water extraction traits are found good, they can be considered. And these traits are like root length density, fine roots, and surface area, which are again well connected, well associated with each other. That is, having finer the roots, you will have more the surface area, and similarly root length density is also more with higher the root length, and like that in the volume which is grown. So the exploratory analysis revealed that lateral root development measured by average root angle from soil surface had inverse and weak relationship with root penetration and water extraction trait. As you can see here, that this is root angle, and you can see with the rest of the traits, there is a relationship which is a negative relationship. That means smaller the root angle from the soil surface, the more the rooting depth, the more the root length, the more the root length density. So likewise, all these traits are well associated, which promotes enhanced rooting depth, high number of folds, high number of crossings, fine roots, and high surface area. So this way, I would like to begin my talking here with a drought-tolerant soybean pipeline, which is a complete workflow starting from a multi-parent hybridization to through analyzing multiple drought-related traits into multi-trait indexing to identify elite lines. What we do here, we start up with, as we all know, drought tolerance is governed by multiple traits, and therefore the very criteria is that multi-parent selection for drought tolerance is very important, and all these traits, the need is to introgress like five six important drought related traits introgressed into one genotype. That's why a multi-parent hybridization approach is adopted to get a multi-parent F1 in 3 cycles. It takes 3 cycles of hybridization anyway. And once these multi-parent F1s are achieved, the method which has been standardized here at Indian Institute of Soybean Research, that is the chemical desiccation test, early generation advanced method. In this method, potassium iodide at 0.2% weight by volume is used as a desiccant, and it is sprayed to the whole plant canopy at 10 days after seed fill stage in F2 and F3 generations in a bulk population. And this way it leads to selection for seed size under desiccation stress. And finally, in F4, what you will get are the bold seeds for in F2, F4 generation. And in this F4 generation, we follow individual vigorous plant selection, large number, and in the coming generation, like in F5, we go for in the we follow three tier trait extraction system, and in this first tier of selection during summertime, we go for delayed wilting trait screening, followed by in the following rainy season, there is we have the opportunity to extract the stem reserve mobilization trait, and finally, when the genotype, those genotypes which have been identified for delayed wilting, yes or no, or maybe advanced to for next generation for stem reserve mobilization trait, and having combined these two traits, either combined or individually, also in the selected genotypes. Those selected genotypes are advanced to 3 tier for the 3rd tier of selection in rainout shelter, where selections are actually made for seed traits, morphophysiological traits, and for root traits, as I already explained in the pipes. Once these data of this large number of data is collected, the very question is to analyze them. So we go for multi-trait indexing, where multiplexing multiple above and below ground traits are multiplexed using principal component for correlation matrix using SAS software, and lines with more than average index value that comes normally to 0, and anything above that very average index value are considered elite drought tolerant line. We consider that they have right proportion, right blend of these traits combined together, and that particular elite line. So the selection intensity all through practice here is 10% selection intensity. So when we start off with, say, taking a large number like 1,000 plants, we keep on reducing that number, and finally to end up with, say, some 5-6 genotypes, which really respond to the drought stress. So just to start up with, very important thing is candidate parental lines for drought tolerance as well as for zonal adaptability. And here in case of soybean, the genotypes or the germ class we have in screen here over the period of time, and they have been identified. And as you can see, for different traits like NRC 136, NRC 137, some exotic germ class like some exotic collections and TGX lines. So the list is provided here, and already very long. Also at USDA also they have done like Young, Jackson, and those PI numbers and R01 numbers. Those all numbers they have been they are available in the germ class repository, and as per the need, the breeder can select out of the available germ class collection for the trait of interest, and it can be crossed with very widely adopted the cultivars of soybean, as you can see on here. So there is an early mature. This is in the context of Indian context, and you can see there are different zones like North Hill Zone, North Plain Zone, Eastern Zone, Northeastern Hill Zone, Central Zone, and South Zone. So these are recently released varieties. So there are again two groups, like early maturity group and medium to late maturity group, and accordingly, these genotypes are crossed to get the target achieved. So to follow the trade, the multi-parent hybridization, as I discussed already, it's a very similar for development of magic population. So it's an eight-way cross, and this magic population at our institute has been developed in yield-related trade also, and taking that advantage to the drought-related trades. The drought-tolerant genotypes are crossed with well-adapted cultivars, and as you can see, P1, P2, P3, P4, and likewise we take eight genotypes, and there are 3 cycles of hybridization. And to reduce this time, we can take advantage of polyhouse control facility, where during rainy season we go for, or we can start with off-season polyhouse crossing and go for another cycle in on-season, and again off-season, and again on-season. So in 2 years' time, you will have multi-parent F1. So these multi-parent F1s are then advanced, as I already discussed, that chemical desiccation is early generation advancement. So early generations are therefore subjected to undergo chemical desiccation stress. F2 population is spread with the chemical desiccant potassium iodide over full canopy at seed fill stage, and seeds harvested are pearled to separate bold size, that is maybe more than 12 grams, through mechanical sieving. So it's a very kind of broad way of doing it. So then select multi-parent parents with the very here the point to note is select multiple parents with similar maturity group in order to synchronize seed fill stage for ensuring uniform spraying at the same growth stage for all the plants in the population in a particular generation. So the same selection process is repeated in F3 generation as well, and in F4 generation, selection for approximately 500 individual vigorous and high-yielding plants is effective, and This has been already reported by Bloom et al. In 1991, long back, that mass selection for grain filling under chemical desiccation to improve stem reservoir support grain filling supports for grain filling was successful when performed in F2 and F3 generations. So three-tier selection scheme is practiced after F4. So a three-tier selection scheme was developed for phenotyping and selecting germplasm and advancing breeding lines, both for to F4 generation onwards, targeting delayed senescence in the first tier, stem reserve mobilization in the second tier, and drought tolerance and yield related trait under rainout shelter activated water limited condition, and root system architecture trait in the third tier for identifying drought tolerant germplasm and lines. So in this scheme, the three-tier selection scheme is applicable for drought-related traits and was developed to identify candidate soybean lines with high tolerance to nitrogen fixation. And this scheme was proposed by Sinclair in their selected traits for nitrogen fixation. So the very first tier, the broadest and least accurate screen, the very first tier was based on concentration of urids in the petiole and 10% germplasm selected from large numbers. And then in the second tier, you can see here, another 10% of these field-tested germplasms were selected for nitrogen accumulation under drought. And in the third tier, the screening was performed for intensive measurement of nitrogen fixation response to soil drying in greenhouse. And finally, novel excisions were identified that had substantial superiority in nitrogen fixation tolerance in soil drying. So this is another part of the world. So and in this on the similar line for high productivity traits under water limited scenario and selection at 10% intensity in each tier, as you can see here, by taking around 1,000 germplasm excision. And the first tier is the broadest, again the same, the least accurate scheme for the trait. Here the trait is chosen as delayed leaf senescence. It is done in off season, and out of that, another of 10%, that is 100 germplasm selection for this very trait, delayed leaf senescence on 1 to 5 rating scale, with 5 being the tolerant one. In the second tier scheme, the excisions were selected for stem reserve mobilization trait during Kharif season, and with this in this technique, this is the advantage that it can be done in Kharif season as well. The only thing, there should not be rain at the time of pot filling stage. In the third tier screening, with that we go for another 10% of selection, and third tier screening was performed for measuring above ground plant and seed traits in rainout shelter and root system architecture traits in lysimetric PVC pipes, rhizomic wind rhizo root scan phenotyping facility. And likewise, novel excisions and lines were identified on the basis of indexing drought-related multiple traits having substantial yield superiority in soil drying, and precise phenotyping here to report that. Precise phenotyping is must for capturing drought response and related traits in soybean. Otherwise, you are going to lose some of the genotypes and some of the traits. Finally, when you come up with all that large number of traits, the main challenge remains how to identify a genotype having one trait or the another into it. And that makes the job still more difficult, but the statistical tools and softwares has made this thing easy, and multi-trait indexing using principal component analysis for correlation matrix using SAS. Here you can see a multiple trait index was used based on principal component analysis for correlation matrix, and with this formula given here, the software calculates by itself, and the lines having value above average index value that comes always most of the time comes to 0 were considered uh, the best performing lines. So above the 0 value, the line which is having more than this value, this average value, will be the best performing genotype. That is, we think, like like here is for example, and it is just an arbitrary data I have used. So like large number of traits like drought related traits where drought resistance index for seed, this is the first column, drought resistance index for seed weight, the last column, a rooting depth, there is another one. Then there is a thickness, then surface area, root volume, and average root angle. Likewise, here also like this carbon stimulation ratio, relative water content, pot field moisture content, canopy temperature. So all these traits you can see here, and these are the genotypes, and these are the values for different traits. They are indexed into a value you can see here, and here finally what it comes like the average values, average value, mean value, as you can see here, it comes to 0, and anything above this value, is considered as the best performing genotype. And if you have a particular check, you can see the check is coming to 0.6, and that is the tolerant check, and the susceptible check that is coming to minus 0.2. So here it predicts that it is having combined together all these traits into one index, and anything above 0, they are all good. But it's still, if you have a check like tolerant check, and anything above this 0.6 value is even better, which you can consider it for as a candidate parental line, or if it is performing really good in the field condition, then go for releasing as a cultivar. With this, the novel drought-tolerant germplasm and elite lines like NRC 136 and NRC 137, likewise, they have been selected for drought resistance index. Out of this, you can very specifically germplasm are also identified out of so many traits. Trait-specific germplasm can also be selected, and you can see there are traits for delayed leaf. There are germplasm for delayed leaf senescence traits. There are traits for drought resistance. They are having a good root architecture. So these genotypes and associations have been identified. And here I would like to give you a case study out of what at the Institute of Soybean research that we found. At NRC 136, it's a newly released variety of soybean for eastern zone. And the area under soybean cultivation is fast picking up in the eastern states of India, that is West Bengal, Bihar, Jharkhand, Orissa, and Chhattisgarh. Occurrence of drought every alternate year in this region discourages farmers from soybean cultivation. The Indian Institute of Soybean Research Indore recently developed a variety NRC 136 for this region, which has an average yield of 17 quintals per hectare and can give up to 30 quintals per hectare under good agronomic management practices. And in previous experiments in renowned shelter, it has given 30% yield advantage over a popular variety in this region, JS97 5052. So NRC 136 is highly resistant to Indian bud blight. It's a prominent disease of this region, eastern region of India, and shows moderate resistance to defoliation. It's a common insect of soybean. And notification of NRC 136 by Government of India for this region is very timely and will help in reversing the trend uh, for the farmers or for the benefit of the farmers. So similarly, there are other varieties which were evaluated. They have found drought tolerant and having some more other important agronomic and plant protection traits into it, like GS9560, GS2034, NRP7, likewise GS9752. These are the genotypes. So novel phenotyping-based breeding strategies hold the promise in increasing genetic gain and will help identify elite high-yielding soybean lines in an all-inclusive, water-limited environment for improving soybean productivity. Here at Indian Institute of Soybean Research in Indore, efforts are on in identifying new genes and genetic resources and parental lines for drought-related traits, such as developing highly drought-tolerant soybean varieties and cultivars. That's all good, and thanks very much.
So very exciting lecture, sir, and I hope with the diverse group of participants, some of pupils may have queries or suggestions on this topic. So I invite if some queries are there.
सर
हाँ बोलिए सर.
डॉक्टर मेत्र परभनी
Please.
In Marathwada region, especially in Maharashtra, the drought occurrence is only actually there is big gap between the two rains, especially 10-15 days. The temperature is increasing more than 35 degrees, and there is no soil moisture, actually very limited soil moisture in the soil, even for medium to deep soil. And especially the occurrence of the drought from last 2 to 3 years after flowering and pod filling stage.
That's very precise, and that is the terminal.
Then is it possible to introduce this variety, drought tolerance variety in Marathwada region?
Well, that part, adaptability part, is actually All India Coordinated Research Projects part, and based on, as you can also understand, it's like suitability to the zone. The varieties are identified, so it was tested in that area also for the central zone. Maybe if you want to go for a state variety release that can, and it performs very well over there, then you can go for, no problem.
The another one question, sir, which is the important root system architecture traits directly influence the drought tolerance in soybean?
As I've already told, the root system architecture is a very complex phenomena, and very pinpointedly, I will say that that root angle is the most important thing, can be measured in a very simple way. Root angle from the soil surface. Also important is that it should have more than 1 meter rooting depth. The length of the root should be more than 1 meter. Another important is at the lower side of the root. It should be more fibrous nature should be there, so that they can explore more water and all. So this kind of root system is really support the water extraction from a deeper rooted root. And as I told, the root angle from soil surface, narrow root angle from soil surface, another important trait. So when soil moisture is there in the upper root region, it can extract from the upper root region. And when the soil moisture is in the lower substrata, So that kind of food system. So if you have a kind of genotype which is having a combination of these two, will be very much supporting to the genotype for performing under drought stress.
Thank you, sir.
Thank you.
Satpute ji, Dr. Deshmukh from
Sir.
Kasbe Digraj.
Sir, good morning, sir.
Hello.
Sir, please.
So, is there any relation? Is there any relations found regarding this pad chlorophyll meter in other crops, particularly in groundnut? They have they are taking this help of the selecting this material in segregating generation with the help of SPAD. Is there any references or anything? Can we utilize this SPAD for making selections?
Yeah, definitely. In fact, we are using SPAD, canopy temperature, SPAD or infrared thermometer, and all those things. Facilities we are using. Maybe I've shown here, but SPAD is very much a criteria for the greenness and nitrogen content directly. So having more greenness, it will have better drought response. But there are data from outside also, and there is a little variation that need to be standardized. Some where it has been told that less greenness is more important. So depending on the genotype and the type of plant canopy it has, it need to be standardized for SPAD chlorophyll. But in general, for Indian conditions, the greenness is through SPAD is an important trait that can be extracted for this drought tolerant, breeding for drought tolerant. So,
Another my one is submission. This is my submission. Whatever the germplasm available with you, that should be screened for. If you, I don't know. In soybean, what type? Generally, early season drought, mid season drought, and late season drought. Means we can say early season means up to flowering, mid season drought at flowering, and late season pod development. So if you screen this, whatever the germplasm lines or whatever the sources you have, that will be very useful for further breeding. Means,
so
by creating the artificial drought condition at your locations.
Sure. So we are coming up with this project, and this year on we are targeting for early season, early vegetative stage drought also. And with this project, we will try to see if vegetative drought level drought stress can be combated with the number of traits available at vegetative stage, including root traits. That is more important. So I will see the results and will let you know later on maybe.
And another is carbon isotope discrimination facilities. Is it available at ICAR-NSRI in your Indore?
In fact, it is a little expensive facility, and this is available in India at UAS Bangalore with plant physiology department. So that can be contacted and can be made use of for carbon isotope discrimination. It's a good facility.
Thank you.
Anybody else? If you have anybody else have query, you can ask Dr. Ganesh.
And you can unmute yourself and ask the question.
Okay, I think if there is no more questions, we can end the talk. So I would like to thank today's speaker, Dr. Ganesh Kumar Satte, for having such an impressive lecture. I also thank our director, Dr. Anita Khandekar Madam, for her encouragement and facilitation to organize this webinar series. My special thanks to Dr. Sanjay Gupta for all his motivation. Also thanks to Dr. Savita Kole, Principal Scientist Computer Application, and her team for their technical coordination in smooth virtual session. My sincere appreciation and heartfelt thanks are due to the participants who took their time out to attend this webinar. Bye-bye. So now we can end the meeting.
Thank you. Thank you, everybody.
मैडम मीटिंग एंड कर दें.
सर
मीटिंग.
हाँ, close कर दो.
एक मिनट मैम. सविता मैम.
निधि बोलो. हेलो निधि.
मीटिंग एंड कर दे.
ओके ओके ओके.